Assalamu alaikum. Welcome to our first class of mathematics. Our first topic is transformations, and under transformations today's lesson is about translations. Before discussing what translation is, first we will see what is the meaning of transformation and what the word means in mathematics. From the word itself, transformation, it means to transform something. Transformation means a change. That change can be anything, change in size or change in position. Now in mathematics, a transformation is a change in the position or size of an object, or it can be a point even. In IGCSE syllabus, we have to deal with 4 types of transformations, that is translation, rotation, reflection and enlargement. Now looking into the application of transformation, transformations play an important role in computer graphics, animations and architecture as well. Out of the 4 types of translations, our today's lesson is about translation. Now in today's class, we are going to learn how to translate simple plain figures, that is drawing translations, and then how to recognize and describe translations using column vectors. Right now you might not know what column vectors are, but at the end of this lesson you will know what it means, column vectors. Now translation. We know that translation is a type of transformation. Here translation means to move a shape without changing its appearance. So in translation, what we are going to do is we are going to draw the same shape. It has to be in the same size, in the same orientation, but only the position changes. That is what translation is. So this is a transformation that slides an object without altering its shape or size. Now we are going to discuss how to draw a translation. Here is the first example. It says translate the rectangle 5 squares right, 3 squares up. We have discussed that translation is the movement. It is the movement where the object slides. Now the information how to slide the object or how to move the object, that information will be given in the question. Now right now here the movement is we have to move this shape 5 squares right, 3 squares up. That is our translation. Now the object given here is a rectangle. Before the transformation occurs, the shape to the shape we called it the object. The object is the rectangle here. We have to translate this shape 5 squares to the right and 3 squares up. Now to translate a figure, we use 2 methods. The first method is translate using a tracing paper. How to use a tracing paper is just keep the tracing paper on the object, draw the outline of the shape, and we are going to move the tracing paper 5 squares right, 3 squares up. So how to do this one is, already I have drawn the outline of the rectangle. So here our object is, we are going to translate this one 5 squares right, 3 squares up. So this is 1 square right, 2, 3, 4, 5, and now we have to move this one 3 squares up. 1, 2, 3. So after a translation of 5 squares to the right, 3 squares up, this is where the object goes. Now after the translation occurs, we say this is the image of the shape. So I am going to show how the object moves. 1 square to the right, 2, 3, 4, 5. Now the object has to move 3 squares up, 2, 3. So that is where the image is after a translation of 5 squares right and 3 squares up. Now the other method we follow to translate a given shape is we mark one corner of the figure, and we are going to move this point through the translation given, which is 5 squares right and 3 squares up. Move the point 5 squares right, 1, 2, 3, 4, 5, and 3 squares up, 1, 2, 3. So this is the point after translating it 5 squares right and 3 squares up. Now the same way you can follow the remaining corners of the shape, the corner here. Move the point 5 squares right, 3 squares up, and the point here and the point here as well. So when you move these points through the same translation, this is where the point goes. Now this point, check 1, 2, 3, 4, 5 units to the right, 3 units up. Now without moving each and every point through the same translation, which is 5 squares right and 3 squares up, we know how to draw those points, because in translation the size of the object doesn't change, even the orientation stays the same. So after moving even one single point, we know how to fill in the remaining sides of the shape. So the shape will stay in the same size and same orientation. So we know that the point here, it is 3 squares down, so 3 squares down, point here, and then the next point here. So fill in the shape, you get the translation there. So the second method is each corner of the shape must be put through the same translation, which is move those points 5 squares to the right and 3 squares up. We are going to do another example. It says translate the diamond 4 squares left and 5 squares down. Now you can follow the same tracing paper method, which is on a tracing paper, trace the outline of the shape and move the tracing paper with the translation given 4 squares left, 5 squares down. So here I have drawn the shape on a tracing paper. So we are going to move the tracing paper 4 squares left, 5 squares down. So this is 1 square to the left, 2 squares, 3 squares, 4. So that is 4 squares to the left. Now we have to move it 5 squares down. 1, 2, 3, 4 and 5. Now this is where the image of the object goes after a translation of 4 squares left and 5 squares down. That was the tracing paper method. Now let's see the other method, which is identifying a point on the shape. Draw the point. Now move this point through the translation 4 squares left, 5 squares down. 4 squares left, that is 1, 2, 3, 4 and 5 squares down. 1, 2, 3, 4 and 5. So this is the point, the same point of the image. Now what we are going to do is, without moving each and every point, we are going to fill in the remaining sides of the shape. We know that in a translation the size doesn't change and the orientation also stays the same. So now that was the point here. So we have seen the point, that point comes here. Now if I translate the point here, without moving the point 4 squares left, 5 squares down, how to draw is, now from this point to the point here, we know it is across 1 square and down 2 squares. So on your image also the point has to be that way, 1 square across and 2 squares down, because the size of the shape doesn't change. That is where the point goes. Now if you look at the point here, from this point, the point here is to the left 1 square and down 2 squares. So from this point, if we see, across 1 square, down 2 squares. So the point here has to come here, because the size will not change in a translation, it comes here. Now the same way, the last point, so it has to be here, and then you can draw the shape. That is putting each point through the same translation. In IGCSE, we will not be given the movement that move this shape 5 squares to the right, 5 squares to the left, 2 squares down. It won't be given that way. All we are given is a translation vector. So translation vector is very important if we want to draw a translation, what translation vector is. Now Translation vector is a vector that gives the length and direction of a particular translation. So, if you are given a translation vector, it will tell you how and where to move your object. A translation vector will tell you the movement of x units in the x direction. X direction means it is the horizontal direction. Horizontal direction can be either left or right, and the vector will also say the movement of y units in the y direction. Y direction is the vertical direction, whether the object is moving up or down. Now, how to write a column vector? Oh, the general form of a column vector is this way. In a bracket, we write a column with two values in it. The first value, we say it is the x value or the direction in the x axis along the horizontal axis, whether the object is moving to the right or to the left. The second value gives you the information about the movement on y axis, that is the vertical axis, whether the object moves up or down. So, we have seen that the first value indicates the object's movement horizontally, right or left. Now, how do we know whether we have to move the object to the left or to the right? It depends on the sign of the value. The sign will indicate you how to move the object to the right or to the left. Now, our movement to the right is positive. That means, if the first value given here is positive, you have to move the object to the right. If this value is negative, move the object to the left. Now, the second value indicates whether you are going to move the object up or down. That is also a movement up is positive. If this value is positive, then you have to move your object upwards. If this value is negative, move your object downwards. So, instead of writing the movement like 3 squares right, 2 squares up, how to use column vectors to write the same information is, we know that a column vector, in a column vector we write the values in a bracket, two values column wise. The first value indicates whether the object is moving to the right or to the left. Now, here it says movement 3 squares right. So, 3 squares in the right direction, say it is 3 here. Since the object is moving to the right, this value will be positive, and in the y direction, that is the second value, up or down, it says 2 squares up. So, this value will be 2, it is a positive 2 because it is moving 2 squares up. This is how we write a column vector. Now, a very common mistake the students make is, when we write the column vector, translation vector, many students write it in a bracket, horizontal way, 3, 2, which is wrong. When you write 3, 2 horizontally in mathematics, this is not a column vector. These are coordinates of a point, which say x value is 3, y value is 2. Now, another way the students write the column vector is, in column form they write, but write in 3 by 2, which will also not be correct, because in math 3 by 2 means 3 divided by 2, which is 1.5. So, these two methods, these are very common mistakes students make, which is not correct. So, this is how we write a column vector. So, here given some column vectors, translation vectors. Now, what it means, if you have positive 4 and positive 6, this means you have to move your object 4 units to the right and 6 units up, because both the values are positive. A translation vector of -3, 5. Here the first value is negative. So, first value indicates whether you are going to move the object to the right or to the left. Since this value is negative, which means you have to move the object 3 units to the left and 5 units up, because the second value is positive. Another example, the 6 minus 1. First value is positive, so 6 units to the right. Second value is negative, so 1 unit down. If you have -4, -5 as a translation vector, both the values are negative. First value is -4, so you have to move your object 4 units to the left. Second value is also negative, so move the object 5 units down. Now, here is one more example. It says you have to translate the given triangle by the vector 7 minus 3. So, first you have to know what it means by the vector 7 minus 3. We have two values. First value indicates whether to move the object to the right or to the left. Since we have a positive 7, which means you have to move your object 7 units to the right. Now the second value, minus 3, that is the movement along the vertical axis, up or down. We have negative 3, that means you have to move your object 3 units down. So like we have discussed, you can follow any method, use the trace in paper method, you can use the trace in paper method as well. Keep the trace in paper on the object, draw the outline of the shape and move the trace in paper 7 units right and 3 units down. Now what I am going to do here is mark one point on the triangle. Now we are going to move this point 7 units right and 3 units down. Move it. 1 unit right, 2, 3, 4, 5, 6, 7, that is 7 units to the right. Now move it 3 units down, 1, 2, 3. So here is the same point after translating by the vector 7 minus 3. So one way to do this is you can mark the remaining points on the object and move those points through the same vector, that is 7 units right and 3 units down as well. Now without even moving each and every point, like we have discussed, you can fill in the remaining parts of the shape by counting the number of squares, because in translation the size and the orientation doesn't change. So if we look at the point here, from this point the point is 4 units down. So the same point here will be 4 units down, this point here, and then the point here. From this point it is across 2 squares. So across 2 squares, point goes here. So you can fill in the sides of the triangle. That is where the image goes. Another example, you have to translate the object by the vector minus 4, minus 5. The vector here given is minus 4, minus 5, which means you have to move 4 units to which direction? To the left, because that value is negative, and then negative 5 again means you have to move 5 units down. Now here is one point on the object, so we are going to move the object 4 units to the left, 5 units down. So you can count the number of squares, 4 to the left, 5 down. So here is the point on the image, here is the same point on the image. Likewise you can move all the remaining points, 4 squares left, 5 squares down. The third point goes here and the fourth one here. So this is the image after translation by the vector minus 4, minus 5. Now here I have given you an exam question taken from a past paper. It says draw the image of shape A after a translation by the vector 2, minus 3. So you can follow any method, use the trace in paper method, or move each and every point on the object through the translation vector given here. Now here you have to know what it means by 2 minus 3. I think now you know what it means by 2 minus 3, positive 2, so move the object 2 units to the right, and negative 3 indicates you have to move the object 3 units down. So you can mark a point on the object, so move the point 2 units to the right and 3 units down. 1, 2, that is 2 units to the right, now 3 units down, 1, 2, 3. So the point here on the object goes here after a translation by this vector 2 minus 3. Now we can fill in the remaining parts of the shape. Now this point here is 1 square down, so the point goes here, and the point here is 1 square across here. So this is the image of triangle A after a translation by the vector 2, minus 3. Okay, that was all about drawing translations. Now the next part is how to describe a translation. To describe a translation, we have to write 2 points. As the first point, you just have to state that it is a translation, and for the second point you have to write the translation vector, that is the movement the object has gone through, whether the object has moved right, left, up or down. Here's an example where you have to describe the transformation that maps triangle A onto triangle B. Now, triangle A onto triangle B means our object is triangle A and our image is B. The transformation it has gone through is translation. How do we know that it is a translation? Because the object and the image has the same size and the orientation is also the same. So, we know that it is a translation. That is the first point, state that it is a translation. Now, for the second point, write the translation vector, that is the movement. Now, from A to B, what is the movement it has undergone? A to B, we know that the triangle is moving to the right and upwards. To the right means your first value will be positive, and again upwards indicates the second value is also positive. Now, what will be the first value? The same way we have drawn a translation, mark a point on the object. Now, you have to mark the same point on the image. Triangle B is our image and the same point on the image is here. From this point to the point here, check the movement to the right and to upwards. We know that it is going to the right and up. Now, check how many units, count. We have 1, 2, 3. 3 units to the right. So, your first value will be positive 3 and going upwards how many units? 1, 2, 3. Again 3. So, your second value will also be 3, positive 3 because the object is moving upwards. So, how to describe this transformation is, it is a translation, state that it is a translation and by the vector 3, 3 because moving 3 units to the right and 3 units up. So, that is all about translations in IGCSE. Let us recall what we have discussed in today's class. We know that a translation moves the entire object, that means every point on the object in the same distance and in the same direction. And to specify the translation, both the distance and direction of the translation must be given by a column vector this way. If you want to practice questions on this topic, you can go to your textbook. You will have the textbook here. Go to page 565, try the questions on exercise 23.3. That's all for today. I hope we will meet very soon with another topic. Thank you.